Hi there. Welcome to our second video on slope. In this video, we're going to look at some problems that involve you to use the slope to graph lines. And then we're going to look at a couple application problems for slope. All right, so let's get started. So in this first problem, it says to draw the line through the point -3, 6 with slope -5/2. So we need to have a line that goes through the point -3, 6. Okay, well that point I can plot right away. So -3, 6 is right here, right? And the slope being -5/2, well, what does that mean? Well, that means that, remember, the slope is rise over run, okay? So if it's -5/2, that means the rise we can take to be -5, and the run we can take to be 2. Okay? So that means that I'm going to rise -5, which means I'm going to go down 5 units. So 1, 2, 3, 4, 5 puts me there. And then my run is 2, so I'm going to go across 2 units, and that puts me right here. So I did a rise of -5 and a run of 2. Let's do it again. Let's go down 5 from there, and then over 2 again. And that gets me another point, right? And I now have plenty of points to draw a line. I'll do my best on here. I don't know how good I can draw a straight line. I didn't do too bad. So there we have it. We have the line. Okay, so let's go take a look at another one. Draw the line that has slope 2/3 and passes through the point 0, -2. Okay, well, the point 0, -2, I can plot that, right there. And it has slope 2/3. Well, that means that, let's write it down again. This is rise over run. So 2/3 means that my rise is 2 and my run is 3. So I'm going to go up 2 and over 3. So up 2 and to the right 3 puts me right here. Let's do it again. Go up 2 and to the right 3. That puts me right here. Now notice, I want to point out something. You can also write 2/3 as -2 divided by -3. That's an equivalent. Sorry, there's some noisy traffic outside. That's an equivalent fraction, right? So that's saying that the rise is -2 and the run is -3. So I go down 2 and to the left 3. That would put me here, right? Or I go down 2 and to the left 3 again. That would put me here. So any equivalent fraction would work. I could even use 4/6, right? If I started here and went up 4 and to the right 6, I would end up here, right? Which is a point on the line. So any equivalent fraction will work, and that will get me the line that goes through these points. Okay, and what that also means is, maybe I can make another one here. Okay, so draw the line with slope 4, which passes through the point -5, 0. So here, okay, I can plot that point -5, 0, right? That's going to be right here, right? Now, the slope is 4. Now, what we were doing before is we were viewing it as rise over run. How do I view 4 as a fraction? Well, you can write any number as a fraction. You can write that as 4 over 1, right? Or any equivalent fraction. 8 over 2 would work. All of these will give me rise over run, right? So if I wanted to plot the line, I could go up 4 and to the right 1, so that would put me here. Or I could have used the second expression, 8 over 2. I could have gone up 8 and over 2. That would have put me here. I could also use the expression -4 over -1. That is equal to 4. That would say to go down 4 and to the left 1. That would put me here. And all of those give me another point on the line. So I can now draw the line. Okay? All right, so that's using slope to draw lines. Okay, The other thing that I wanted to talk about here are some application problems. So let's go take a look at these. So here we have a leaky tank. Okay, it says a leaky tank starts with 10 gallons of water. 3 hours later, it contains only 8 gallons of water. If the water's leaking out at a constant rate, then what is the rate? What is that rate at which it's leaking out? Okay. Now, constant rate is what you'd see in a line. So that's telling us that this is a linear equation. Okay, so what we've been talking about with slope makes sense. Okay, so remember what we did for slope. Slope was rise over run. But if you recall from the last video, we also had this other formula, y2 minus y1 over x2 minus x1. Okay, now if I'm talking about the rate at which it's draining, that's going to be in gallons per unit time, in this case hours. So we want to know the rate in gallons per hour. So if I want to end up with gallons per hour, for the numerator, I want quantities that represent gallons. So my y's are going to be the gallon measurements. And for the denominator, I want to end up with hours. So for my x's, I want time measurements in hours. So if I look up at the word problem, it starts with 10 gallons. Well, that's my y1. And 3 hours later, it contains only 8 gallons. So that's my y2. Okay, so I can see that y2 minus y1 is going to be 8 minus 10. Now, what's my x2 minus x1? Well, the x, like we said, are the measurements of time. So if it starts with 10 gallons, that's when time is 0. x1 equals 0. That's what starts means. And 3 hours later, it contains 8 gallons. So that's my x2. Right? So for x2 minus x1, I'm going to have 3 minus 0. Okay, so let's see what we get here. We have 8 gallons minus 10 gallons. That gives us negative 2 gallons. I have 3 hours minus 0 hours. That leaves me with 3 hours. Pulling these units out to the side, I see I have negative 2/3 gallons per hour. And it makes sense that it's negative because it's draining out. It's decreasing. So I should get a negative number. And notice that the units that go along with slope have to do with the rate at which something's changing. Right? So slope is a way of measuring rate. Let's go to another example. This example says it costs $100 to manufacture 5 chairs and $150 to manufacture 10 chairs. If cost is related linearly to the number of chairs, then what is the cost per chair? Okay. So you might say, well, wait, if it costs $100 to manufacture 5 chairs, that means each chair costs $20. Well, no, there might be overhead here. You may have to pay for, electricity and paying employees. So that's not what we want to look at, because we don't know that the $100 is all for the chairs, 5 chairs here. Okay, so there may be other overhead. So what we really have to do is use all the information here. Okay, so we want cost per chair. That's slope. That's a rate. Right? So that's, again, something that we'd need slope for. And remember, slope is y2 minus y1 over x2 minus x1. And we want this to end up being cost per chair. So we want this to end up being dollars per chair. So the y's are going to represent the monetary amounts. So let's see, we start with it costing $100, so that's our y1. And we end up with it costing $150, so that's our y2. We start with producing 5 chairs, so that's our x1, and we end up producing 10 chairs. That's our x2. Okay, so that's all the ingredients we need. y2 minus y1, 150 minus 100. x2 minus x1, that's 10 minus 5. What do we get here? Well, this is 50 divided by 5. These are in dollars, and these are in chairs, right? Pulling the units out front, we have, 50 divided by 5, that's $10 per chair. You could write it like that. Dollars are kind of weird. We don't usually write the dollars out front, but if you were to write it that way, you would write it dollars per chair, right? Usually, for some reason, the way we write dollar signs, we put them off to the left, which is kind of confusing, but that's the way we do it, right? Okay, so again, slope is a rate, and rate is going to measure amount per the change in something, right? Okay, so that was some more applications of slope. I hope you learned something there, and I'll see you in the next video.